Good morning to all of you. Am I
Good
audible?
morning, sir.
Good morning. We are studying about energy storage system, and today's topic is flywheel energy storage system. First, we start with a video.
Energy storage flywheels have very high performance and work on simple principles. To understand their operation, it is best to start with the electric motor generator. An electric motor and generator are really the same machine running in opposite directions. When you put electrical energy into a motor generator, it turns into mechanical energy on the spinning shaft. That's a motor. When you put mechanical energy into the motor generator by spinning the shaft, you can draw electrical energy back out. That's a generator. For an energy storage flywheel, we hook a motor generator up to a wheel. When we put electrical energy into the motor generator, it accelerates the wheel, storing that energy as momentum on the wheel. When we want our electricity back, we let the momentum of the spinning wheel drive the motor generator, regenerating our electricity and slowing the wheel. Because we run our flywheel in a vacuum and on very good bearings, we don't lose much energy over time. Velkus has invented a new way to make energy storage flywheels at very low cost.
Now tell me what you understand about a flywheel. What is it exactly? What is a flywheel? It is. Can you tell me what is a
Yes, sir.
flywheel? I've shown you a video of flywheel. Have you understand what is a flywheel? Yes or no?
Uh, yes, sir, but not complete.
Not complete. Okay. So first we see that if suppose this is a flywheel and with that a motor generator set is connected, and if we have AC type supply, or if we are taking AC type supply, then from the motor generator set we get directly, and if we change it into DC type, then we have to add a inverter or rectifier section, because by the motor generator set, what we actually doing, we, in case of, suppose if the motor generator set is act as a motor, then what we do, we provide electric energy. By the providing of electric energy to the motor, we convert that electrical energy to mechanical energy. By this mechanical energy, we store in flywheel the mechanical energy. Actually, you can say the flywheel is like a mechanical energy storage battery. You can say it is a battery. It's like it's stored in the form of mechanical energy. Actually, it is a rotating part. Actually, it is a rotating part by which we can store the mechanical energy in form of kinetic energy. And when the actually when the free wheel rotating, and it stored the kinetic energy, and by this kinetic energy, when we extract from flywheel by a generator, we produce electric energy. And this is AC type. If we want to in DC form, we have to use a rectifier. By this rectifier section, we convert the AC into DC section. Have you understand the configuration of a flywheel? There is some
Yes.
rotating part by which we can store the mechanical energy in the form of kinetic energy, which is actually rotating part, and the rotation or the mechanical energy we provide by a motor generator set. When we supply the electricity to the motor generator set, the motor generator set act like a motor and convert the electric energy to the mechanical energy. And by the mechanical energy, if we provide to the flywheel, then we can store the mechanical energy in the form of kinetic energy. And how to retrieve that kinetic energy? By the flywheel, it is rotating, and if we provide that rotation motion to a generator, it produces electric energy, and this is in AC form. If we want in DC form, then we have to use a rectifier. I hope you have now understand what is actually flywheel. And the figure or say diagram of a flywheel, you can see in the screen. And the flywheel actually, the inner part is the flywheel, which is actually rotating part, and the outer part is mechanical support part, you can say. And you also can see clearly from that figure, there is actually the flywheel rotor is that part, and this is motor generator set. And when we rotate something, then we use two bearing on the two end. It's like that. When we rotate something, we use two bearing on the two end part of the shaft. Am I right, Deepak?
Yes, sir.
Ritesh?
Yes, sir.
So if we use ball bearing, what will happen? Tell me. We rotate, suppose we rotate something, and in the two end two bearing is there, and we rotate some thing, take it as flywheel, we rotate that flywheel, what will happen? We provide the mechanical energy to the flywheel, and it will rotating in motion, and we just left that, what will happen? Is the energy decaying, or it will continually run for year and year? Ritesh,
Sir, repeat again.
suppose I have a flywheel, and in the two end we use ball bearing, and when I provide the mechanical energy to the flywheel, and after that it will rotating. Suppose it will rotating in 10,000 RPM. Suppose by the motor we provide to the flywheel the 10,000 RPM speed. After that, we cut the electric supply, and it will freely rotating, the free the flywheel is freely rotating, with the help of two ball bearing. What will happen now?
So after some time, the speed will reduce and motor uh, tends to stop
Motor will
due to the
going
frictional
stop because in the ball bearing there's some energy
friction.
losses
Yes.
due to the friction. Due to the friction in ball bearing there are energy losses, and if the flywheel rotate in air, what will happen? If the flywheel rotate in air,
So there is a air
there is also
so there
air
is a air
friction.
friction.
Yes, there is
Air
also
drags
air
the air
friction,
drag.
due to which the speed of the flywheel will decrease gradually, and it will the speed decreases gradually. So can we use the 2 and 2 ball bearing and the cylinder full of air? Can we use like that? Or we have to use something else by which we reduce the friction and it will rotate for year and year? Can we use ball bearing or we have to replace the ball bearings by something else? Rahul?
Sir, without well bearing, how we can collect rotational motion? I think ball bearing is necessary
Oh,
to collect
how
rotational motion.
actually by which we replace the ball bearing? This is your question. Ritesh?
Means new instrument.
No, actually you are saying that what is the replacement of ball bearing?
Yes, sir.
Okay, I will tell you
Which
later.
device or
Okay, okay, okay,
component?
okay. I will tell you later. First, actually, we have to replace the ball bearing and the surrounding air. We have to replace this some. Suppose we have to replace the ball bearing by some other means of bearing, and we have to evacuate the air, the surrounding of the flywheel. By this means, we can reduce the friction so that it will rotate for a long time. If we do that, then it will rotate for a long time. Am I right?
Yeah, yes, sir. It will rotate for a long time, but it not continue.
Continually
After some
rotate
time,
for
it
long time.
falls.
You are saying that. If we suppose,
Yes, sir.
if we make something or if we replace the bearing by some means so that the friction is near equal to zero, so what will happen?
Then it possible.
Then it possible.
Yes, sir.
Okay. First, we have to make the housing so that this flywheel should be in vacuum. First, we make a housing over the flywheel system, and the surrounding air we have extract by a vacuum pump. Can we reduce the air friction by this means? It is, if we extract the surrounding air by a vacuum pump, can we reduce the air friction?
Here vacuum pump use both end or single end.
We use a vacuum pump single
Oh,
because we have to evacuate or extract the air surrounding of the flywheel, and we make a housing.
yeah, then can reduce the friction.
Yes, if we extract the air from that housing and the surrounding air are less, and we can say it's nearly vacuum because ideal vacuum is not possible. So by this means we can reduce the air friction. with the flywheel?
Yes, sir.
Okay. And suppose first we'll go to the magnetic one. Okay. First see what we actually replacement of ball bearing. I think you have not seen it properly. See that? What is that? We can replace the ball bearing by a magnetic bearing. Have you seen how it will work? And see that the shaft is lifted when it will rotating. Have you seen that? It is
Yes.
when we actually supply the energy, electric energy, then at that time the shaft will rotate in air. You can say rotate in air. That means there is no physical touch between the coil or say core and the shaft. If we replace the ball bearing by a magnetic bearing, we can reduce the friction tends to zero or nearly equal to zero. You can say. So tell me how we reduce the bearing friction and air friction. It is now you tell me.
Yes, sir. By using magnetic bearing, we can reduce air friction
Reduce
in
the say
case of
ball
ball
bearing
bearing.
friction and making a vacuum the surrounding to the flywheel. We reduce the air friction.
Yes.
Now in
Excuse me, sir.
construction, we have a spinning rotor. In flywheel, we can easily see that there is a spinning rotor of flywheel. Actually, it made by steel or carbon composite. If we use, actually there are two types of flywheel use. One is for low speed use and another is for high speed. For low speed, we use the steel rotor, and if we use the flywheel for a high speed, we have to use carbon composite rotor. The rotor still can spin at several thousand RPM, but in case of carbon composite, the spin is up to 60k RPM, 60,000 RPM. So, because the carbon composite material is lightweight and the mechanical strength of carbon composite material is more than the steel. So, when we actually rotating something, the mechanical strength of that material should be high. Can you tell me why? If we use, suppose the rotating speed is 2000 rpm, and if we uh, use a flywheel of rotation 50,000 rpm, why we need more mechanically strong, actually mechanical strong composite material by which we have to use, or by which we construct the spinning rotor in case of high speed. Can you tell me why? What is the actually problem, or actually what is the cause in case of high speed, so that we have to make the rotor of high mechanical strength composite? Can you say me that? What is the reason due to which we need high mechanical strength material for high speed? Rahul, Deepak, can you tell me why we need more mechanical strength for high speed rotation? Ritesh,
Sir, high speed rotation, we need more mechanical strength.
more
It
mechanical
is
strength material. Why? Actually, why? What is the reason behind it? Why we need that?
here load is maximum.
No, 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 no. Due to not load. Do you know what is centrifugal force?
Yes, sir. Yes, sir.
So tell me, suppose there is two rotating thing, one speed is low, another is high. In which case the centrifugal force is more,
So where the speed is high.
where the speed is high. So though the centrifugal force is more, that means the material which used for high speed rotation, so the mechanical strength of that material should be high. Otherwise, the spinning rotor will break.
Take, yes.
So, for the high speed rotation, we use carbon composite material, and for low speed, we use steel material. Okay, you got my point, I hope. And in case of bearing, mechanical bearing are not practical due to the friction, and the friction is actually directly proportional to the speed. So if we use high speed, that means in case of that, the bearing friction is also high. So due to the friction, the energy will loss too much due to the only friction of that bearing. So we have to replace the mechanical bearing by electrical bearing, or you can say magnetic bearing. And how we reduce the air friction?
By creating vacuum.
By creating vacuum. And this is basically different configuration of flywheel. You can say this is basically the flywheel rotor, and this is basically the motor generator set. Conventional type, what we do that in the housing, both are in inside, and it may be the motor generator set may be outside, we can say. And there, in integral type, the actually the rotor part of motor generator set with coupled with the flywheel rotor. And there are or two configuration. In this, we can you can use uh, the flywheel rotor is outside, and the rotor of that motor generator set is inside, you can say. In this configuration, what will you do? In all the things are in within the housing, the rotor flywheel, or flywheel of the rotor, and the motor generator. And in second figure, what we'll do, the motor generator set is outside of the housing, and in third figure, what we'll do, the rotor part of motor generator set and the flywheel is basically same thing, you can say. And in figure 4, what do we do? We actually do the motor generator set, the inside of the rotor flywheel. And in fifth configuration, it also we can do that the rotor or motor generator set are inside of the flywheel. Have you understand the configuration of flywheel? It is.
Yes, sir.
Have you understand what kind of configuration are we used in flywheel?
Yes, sir.
Before actually have to calculate how we actually increase the storage energy of a flywheel. We are storing the energy in which form? Tell me.
Mechanical form. Kinetic energy.
Kinetic energy form. Okay. Suppose we have a rotating part. What is the kinetic energy of that system?
Half J omega square.
Ek is equal to half
Half J omega square.
n v square for linear system. Half mv square is for linear system, but we are using here, what we use here, a
Rotational system.
rotating system. So what should be the kinetic energy of that system? Half
J omega square.
j omega square. And you can also write the j by I. You can also write like that. That means you can also like write, you can also write half I omega square, and I is also moment of inertia. If you used the notation j, what is j actually? J is moment of inertia, and here we use I as moment of inertia. And what is omega? What actually omega?
Angular velocity, angular speed.
Angular speed, you can say. We have to store more kinetic energy. What we should do? What we should do? We have to increase more kinetic energy. What we should do? Either
Increase
we have to
angular speed.
increase the moment of inertia, or either we have to increase the speed. Though we can write ek is proportional to I and proportional to omega square. So by increasing moment of inertia we can store more kinetic energy, or by increasing the angular speed we can store more kinetic energy. Have you got my point?
Yes, sir.
If we increase the speed, if we increase the speed, what will happen? And which, and you can say which factor we have to concentrate more? If we increase the speed, we have to concentrate on mechanical strength, or you can say the strength of the material. If we increase the speed, then we have to use high mechanical strength material. So the
Yes, sir.
costing of the system will increase. You can say the costing of the system will increase. So what we do actually, we increase the moment of inertia of the system. So to increase, or what is the formula of what is the formula actually of moment of inertia of a ring system? Suppose I have a circular disc. Suppose I have a circular disc. What is the formula of moment of inertia of that? What is the formula? I is equal to, suppose the mass of the disc is m and the radius of the circular disc is r. So what is the value of moment of inertia?
Sir, mr square.
Half m r square. So if we want to increase the moment of inertia, what should we increase? Now tell me, if we want to increase the moment of inertia, what we have to increase?
Mass or radius?
Mass or radius? If we increase the mass, what will happen? The system is heavy.
Yes, sir.
We we want a heavy system or light system?
Flat system.
Light system. So we cannot increase the mass of the system. So what we use actually in the first, when I actually play the video, what you will see, they use actually hollow cylinder. By that, what they do, they increase the mass, or you can say they extract from the mass from the center and deposit on the radius or circumference or periphery, by which we can use or we can increase the moment of inertia. And the formula of that time is become I is equal to half of m r1 square plus r2 square. What is r1 and r2? R1 is the inner radius and R2 is the outer radius at that time. So by this configuration, we can increase the moment of inertia of that system. So by this we increase the moment of inertia. So increasing the moment of inertia of that system, we increase the kinetic energy stored on that flywheel. Have you understand that?
Yes, sir.
And how much storage? Suppose the speed of the initial speed of the flywheel is suppose n1, and after that we increase the speed of the flywheel to n2. Then how much actually this energy is increasing, or how much the kinetic energy stored by that flywheel? Suppose the first case, in first case the speed is how much? Suppose the speed is n1, and we know that the relation between the speed and omega is 2 pi n1. You can say omega is equal to 2 pi n. So the energy increasing, how much? The kinetic energy how much increasing after getting from n1 speed to n2 speed? How much energy will increase? What is the formula actually? Half I omega 2 square minus omega 1 square. That much actually energy is increasing. When the speed is omega 1, at that time the kinetic energy is half I omega 1 square. And when we go to the speed omega 2, that means uh, angular speed is omega 2 and the rotational speed is n2. At that time how much energy will there? Half I omega square. And how much the energy storage at that time? Tell me. When the speed is say n1, at that time the kinetic energy is half I omega 1 square. And when the speed is n2, or angular speed at that time is omega 2, at that time the value of the kinetic energy is half I omega square, I omega 2 square. And the kinetic energy increase in between the speed n1 to n2 is half I omega 2 square minus I omega square. Have you understand, Ritesh?
Yes, sir.
Okay. That means we can increase the kinetic energy by increasing the speed. And when we actually provide the electric energy to the motor, then the motor will convert that electric energy to kinetic energy. By this kinetic energy, or you can say rotational speed, in the form of rotational speed, we use the, or we provide the kinetic energy to the flywheel rotor. So by this arrangement we can store, the energy, or you can say excess energy. When the off peak demand is there, we store the electric energy at that time. By using a flywheel we can store, and when the peak demand is come, at that time we extract that kinetic energy, and by a generator set we convert that kinetic energy to electric energy and provide the energy or electric energy at the time of peak demand, you can say. Have you understand that, Ritesh?
Yes, sir.
Okay, now we have to go to the attendance part. Ritesh,
Present, sir.
Rahul, Rahul,
Yes, sir.
Anish,
Present, sir. Present, sir.
Tanushree, Tanushree, Deepak,
Yes, sir. Yes, sir. Sir Tanushri.
okay, Anjali,
Yes, sir.
Avinash,
Yes, sir.
Preeti, Preeti, Akshay,
Yes, sir.
Pijus,
Yes, sir.
Pooja. Okay, you may leave now.